Bum 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 bum.
Tomatoes?
Hello, welcome to video 4, an Unreal concept, simple housing decoration. Let me run you through our example, then we'll run through the code. I have a feeling this video will take longer than normal just because of how semi-complex it is, but we'll hit all the key points. So we have two houses. We have a house A and a house B. If we go to the house, we can interact with it. Once we go inside, well, you can see my awesome decoration job. If we were to leave, we would exit, and if we were to go back in, we would be able to come back in. The layout of the house was designed by me. I can add new items. I can move new items. So for example, if I was to push the 1 key, it's going to put a painting wherever I'm aiming at. I can resize it with the mouse wheel. I can use the E and the Q key to rotate it. And if I put it down, I could pick it back up again, put it somewhere else. I could delete the item, for example. So let's say I don't want the bed on the wall. Let's go ahead and put it back over here on the ground, and we'll put it right here. We'll take this picture and put it here. We'll add another picture here, and we'll size it up a bit. I have too many lights on the top, so I'm going to delete that light, and we're going to go ahead and put it over here. We'll scale it down a little bit, like that. And then we're happy with this. We're going to leave. We're going to come back in, and you'll notice everything is exactly where we had it. Now, each of these houses has their own unique interior that is to that house. So if we were to go into this one, we'll find this house has a different setup. We can also go inside of the house, and it looks like I broke the code for coming out properly, so I'm going to have to check that. But we can go back into the house, and we actually can save and load different layouts. So for example, if I hit the L button, it'll ask me for the name. Let's go and name this one as mine, and I'll hit save. I'm going to close that. Let's go ahead and delete everything because I can. And we're going to go ahead and just set up something really simple like that. And then let's put another light here because we can. There we go. We'll do that. We'll go ahead and hit L. We're going to take this layout and we'll call this one alternate. And we'll save this. Now I want to go ahead and leave. Now when I come back in, we're going to have our default layout set up, which is right here. If I wanted my other layout set up, so for example, I wanted mine back, I could type in mine and hit load, and it will load mine up. Or if I wanted the other one, I could type in alternate and hit load, and it will load the alternate. So let's go ahead and look through all the code and see how we did this. And we had some errors because I left while I had a something running. I don't apparently have all of the safety checks in, but we'll cover that and I'll clean that up. But we'll just cover the basics of how this works. So the basics of how this works. I tried to make this as modular as possible and as extendable as possible. We're basically, let me run you through it again. We're basically going to go into our house. When we go into our house, we load up a separate map. When we load up a separate map, it's going to take the save game from that map. It's going to grab the location of objects and the transformation values of those objects, spawn in new actors, so for each of these items a new actor, and then place it into the world. If I push a button on the keyboard, 1, 2, or 3, it's going to basically, using a line trace that I'm tracing out right now, place the item at the hit point, rotate the item so it's based on the normal, so I'm against the wall is bouncing back to me, so it's going to place the back of the item on the wall, and then it's going to continue to update it every frame, the location rotation. When I scale with my mouse, it simply adjusts the scale locally of that item, and if I rotate, it adjusts the rotation of the item. When I click my mouse button again, it simply lets go of the item and stops moving it. When we mouse over, because we're line tracing every time, it's going to tell the item to glow, and then when we don't mouse over it, it stops the glow. Deleting is pretty simple. We can pick up and hit the delete key. It'll get rid of anything attached. Or if we're aiming at something and hit the delete key, it'll go ahead and get rid of it. Let's go ahead and load up mine. And we'll go ahead and exit. And Each of these is separate based on the name of the item itself. And we can ignore any errors for now. We'll go ahead and correct those as needed. Now let's go ahead and look at the code. So we have two houses. Now, this was designed poorly. This is not the proper way of designing the houses. If you look in our house A, we see this code. And if we look at house B, we see this code. And you'll notice the code's the same. A parent house should have been created, and then all this code would have been in the parent actor. So that's something to keep in mind. Again, this is a concept. This is to show something working. I will point out some bugs and some issues and things that should be worked on if you want to move this into a more professional production quality thing. So you should have one class for both of these. But it's pretty simple. What it's doing is we are taking, when we interact with the door, we are checking the spawn point of the door and saving it to our game instance. This is how we know where to come back to once we leave. After that, we are simply opening the level called interior level name. That was designed so, for example, this house has on its properties the name of the map for the interior. So this map is linked to this map. This object is linked to this map. This object is linked to this map. So it makes it really simple to have multiple objects go to different locations or the same location. It's all designable. It's simply going to load up this map, which is one of these interior names. In terms of overlapping, this is simply our display. It's simply whether or not our widget shows up or our widget is hidden when we walk close to the door or we leave the door. That way we can only interact with the door when we're next to it. Once we go ahead and we interact with the door, we're basically going to load up the map. So let's go ahead and look at our maps, load them up, and well, you'll notice nothing. Because I have set these maps to be done at design time, they're basically empty and lightless. You could obviously have pre-built rooms and have your player just decorate. This is just for an example. It's a room. It's literally another map that loads up. The player is spawned in at the entrance point right here, and then that's it. It's just a map. It's a map. You're loading up another map. It works like anything else. The key here in the map is going to be our interior house manager. Now our interior house manager, which we have here, is basically the backbone of most of the code for handling the loading and unloading of all of our items. We have a debug statement here, which is pretty simple. All I'm doing, if I hook this up, is it's going to clear out the save game. The save game by default is the name of the level we're currently in. It makes it simple. If you want to allow them to have multiple layouts, which I'll show you how to do with my loading thing, you can do that and maybe store the last layout they used or store a default layout. But by default, every interior will have its own save slot. So if you have a player has 10 different houses they can go into, or you've designed 20 different buildings, if each building has its own map name, then each building will have its own interior when the player loads it up. So it made it really simple. Our begin play simply fades our camera out. It's for aesthetic purposes while we're loading up the interior, so that way the player can't see things pop into play. And then we handle entering the interior. The entering the interior is the key to loading up our save game if one's available and spawning in our objects. Pretty simple. Because we designed it around the level name, we can go ahead and just get the level name, check for a save game, and if we have a save game, we load it up. If we don't, we create a new one. So it's pretty simple. If we already have something, our save game object will contain items. If we don't, our save game object will contain nothing. The key to getting things working is this code right here. We grab our save game object. Inside of our save game object is an array of saved interior objects. We loop through each of these objects. It is a struct that contains the item class. So in this case, it could be the painting or the bed or the light. The transform of the root. Where in the world is this going to spawn? Or where in our house is this going to spawn? And then the actual mesh transform. How is this mesh scaled and how is this mesh rotated? These are kept separately. So that way we simply place the item somewhere and rotate the item correctly based on where it's hitting or where it's going to be on the wall. And then we can scale and rotate it separately independent of where it's actually at physically. We spawn it in based on where it is in the world. We grab the static mesh, which is part of our decoration, and we set its relative transform, or its local coordinate space, to the meshes transform, which we saved when we save it out. So that way we're going to spawn it in the bed, and it's going to go wherever we want it in the world, and then we're going to size and rotate the bed based on what it was when we saved it. And then we tell the camera to fade back in once all of our items are loaded. Our saving process is pretty much the same, just in reverse. When we exit the interior, see if we have a save game. If we do, load it up. If we don't, we create a new one. This isn't really a big deal here, mainly because of the fact we're not going to do anything with the existing stuff. Right here you can see we cleared out. But for uniformity's sake, for example, let's say you want to take this section of code here, if you notice they're the same, and collapse into a function, you could. Because the biggest difference is this section of code is unique to loading, and this section is unique to saving. But I kept it there just to show how unique it is and something you might want to do, putting these in a universal function. For safety reasons, we simply clear out the variables of our saved interiors. We grab all of our interior decorations based on the parent. Now that's a key I will point out, but basically all of our decorations have a parent class, and then they are all children, so that way we can easily grab all of our decorations with one node. We loop through all of them. We're going to go ahead and get the class of that object and save it to our array. Get the actors transform, where in the world it is, save it as the root transform, and then get the meshes relative transform, or how is it rotated and scaled, and save it to the mesh transform. We create a new object inside of our array, and then repeat over and over until we've done it to everything inside of our scene. So basically we store all those values for every decoration, grab our current level name, and tell it to save it out to a slot. And then we call finish saving. Now this one's important right here because the exit right here are, let's make sure we can target it. Come on, you can do it. Where's our exit? Here we go. Our exit volume is a separate volume inside of our area. It's a separate blueprint, and it basically talks to our manager. You can see it right here. Tells it to handle exiting and then binds an event to when it's done. So that way when it's done, the door is going to go ahead and handle transitioning out to a different level. Now we are going to, let's see, we have that. So that's our saving and loading. This simply handles our camera, like I mentioned before, fading out to black or fading in, basically when we're done. And that's it for the actual saving of our, let's close these down, saving and loading once we go in and out. It's basically going to iterate through all of our objects, save it or load it based on if we're entering or exiting, and that's it. It's not really that difficult. Other things of note. We have our, let's see, character. So our character is important because our character, as you can see, is really tall, but it handles basically our interaction. We can ignore this stuff. This is our simple movement stuff. But we have our collision stuff here. Our collision stuff is, hey, is something colliding with us? Is that something that's colliding with us interactable? So our doors, our exit or our entrance doors. If so, add it to our list. This is kind of weird. Technically, you should design your levels to not have more than one interaction point at the same time. But to show a way of interacting with more things, I basically created it like this. I created it like this on purpose. Anything that's interactable, we'll add to our list. And when we leave, we remove it from our list. This is basically a list of things that are around us that we can interact with. If we interact with it, it's really simple. We basically use a blueprint interface, talk to each of those items, and tell it to interact with. So the nice thing is technically you could have a door and a light switch both within the same range of you. And when you interact with it, it might toggle the light switch and then open the door. Because you've kept an array of everything you can interact with, an array of everything you can interact with, and then you tell it to interact with them all at once using a blueprint interface. Our tick is our main function, basically our main event inside of our character, because it handles our line trace, it handles moving the decoration to the new spot, and it handles toggling the glow. It works pretty simply, even though it's this big old monster code. It's actually a couple branches. We fire off a line trace forward, and we make sure we ignore any decoration we may be handling. Handled decorations are decorations that we have determined we are going to work with. We're picking up, we're moving, we're spawning, we're scaling, we're rotating. This is our reference to whatever we're working with. Because if we do not ignore that, our line trace is basically going to hit the object, because we're handling it, move it closer to us, the next frame hit it again, move it closer, and we're just going to see the item zoom in on us, and we're going to wonder why everything exploded. When we hit something, we go ahead and just check. We don't want to run any code if we don't hit anything. So if we hit nothing, we're going to go ahead and basically null out or dereference our stored variable for the last decoration we hit, the actor we hit, and any hit results. We're basically going to clear everything out because we're not hitting anything right now. If we did hit something, well, then we're going to store our hit result for later use, store the actor we hit for later use, and then check and see if we actually have something handled right now. Because if we're hitting something and we're handling something, we need to do the appropriate code. So this should actually, oh, it does have a comment, it's just hiding. There we go. I knew it had a comment. There we go. Are we currently handling something? If we are handling something, then take the decoration we're handling, set its location to wherever we hit, and then set the rotation to the opposite of our normal. So if we get our normal, get a rotation from the X vector, this is basically going to be the opposite direction of what we hit. So if we fire at a wall, the hit location will be wherever we hit on the wall. The trace through the wall will continue forward, but the rotation from X vector on our normal will give us back a facing direction, so facing the opposite direction of the hit. So when we set the rotation like that, that's how we end up getting items to stick to the walls. That's why when we move our item, it looks like it's going to adhere to the wall rather than just going into it. Now, if we're not holding anything, we need to see what we hit. Did we hit a decoration or are we hitting a wall? If we hit a decoration, well, is this the same decoration we hit the last time? We don't want to toggle or glow every single frame if we're hitting the same thing. So basically, okay, are we hitting a decoration right now? If it's the same thing we hit last frame, well, we do nothing. That means we've done nothing. We're still looking at the same thing. If we've hit something different, so for example, our hit actor is now a decoration, and the last decoration we hit was nothing. We're going to check, do we have a last decoration that we hit? If we have a last decoration that we hit, for example, we're going from one decoration to another, we need to tell the old decoration it should no longer glow, and then we're going to go ahead and set the last decoration we hit to what we currently hit. So basically, one decoration to another, toggle off the old decoration, store a reference to what we just hit, our new decoration, and tell our new decoration to glow. So that's how we can toggle our glow for our decoration. Now, is the item we hit a decoration false? Basically, we've hit a wall or something like that. Check and see if we have a last decoration that we hit. Are we going from a decoration that's currently glowing to the wall, for example? If it is, we need to make sure it's a valid object that we had in the last decoration hit, toggle the glow off, and set our last decoration hit to nothing. We've gone from a decoration to a wall. Tell that decoration no longer glow, and then we now have no decoration we're hitting. If it's false, we're going to go ahead and also clear the reference to our last decoration. So this handles our glowing and moving our mouse around and basically properly glowing and keeping references. That's what this section does. So it looks like it's a lot, but it's pretty simple. Trace out a line. If we hit something we want to move, we're going to move our current attached decoration. If not, we're going to toggle glows if we need to. That's it. This one's our handling of the action button, or the left mouse button. Are we currently handling something? Well, if we are, then that means we want to drop what we have, so we simply set our handled decoration to nothing. So we have something, and now we don't. If we click the mouse button and we don't have anything, well, that means we want to pick it up. Check to see if what we're hitting is a decoration. If it is, set our handle decoration to that item. Dog nabbit. Oh, there we go. Are we targeting an item? Well, we want to pick it up, and then we toggle the glow off. Because when we were targeting the item originally, it was glowing. Now that we've picked it up, we no longer want it to glow. And of course, if you want it to glow when you pick it up, you can just remove this. It's all customization. So, what's our next thing? Well, handle spawning in our decoration when we press the hotkey. So on our interface, as you noticed, inside of here, we have 1, 2, 3, and L. That handles our 1, 2, 3 in our interface, and it passes it along to our character for spawning. I'll show you how it's set up now. It's actually pretty simple. Here we go. And it's 1, 2, 3, and L with our little layout. And all we're doing is setting up listeners for keys. Is our key 1 pressed? Tell the character to spawn this decoration. Key 2 pressed? Tell the character to spawn this decoration. Key 3 pressed? Spawn this decoration, etc., etc. And that's this code right here, spawn this decoration, and we pass in a class. If we are not handling something, are we handling something? Yes or no? If we're not handling something, then we're going to spawn in something new. If we are handling something, then obviously we don't want to spawn anything new. Now, this is actually a place where you can put in a pretty cool little feature. If you don't have this code here, it's always going to spawn in a new actor and always store a reference to the new actor. When it stores a reference to the new actor, we're no longer holding a reference to the old actor. So let's say you have a painting. And we go ahead, actually I can just hook this up right here and I'll show you how it works. So let's say we're inside of our house and we have a painting. Normally I need to click the mouse button and we drop it. Now let's say I have another painting and we go ahead and we hit the painting button again. It drops the current item and we now have another painting. So this is a way to quickly build stuff by hitting the keys. Because we no longer have a reference to the original item, we're not going to move it, it's just going to stay where it's at, and we just pick up basically another painting. Again, it's a personal choice on what you want. For if you're building stuff with unlimited resources, that may be an option. If not, you'd probably want to double check and only allow them to build things when they have the resources. Spawn in the actor we want. Spawn at the default location, we really don't care. Tell it, hey, we now have a new handle decoration. Figure out where we hit last. This is our hit result that I have split up. So for example, if we were to take our hit result here, and I was told to split the struct, that's how we get this result right here. This is just simply our, recombine. This is our hit result simply split apart. This is our hit result from our earlier line trace where we again saved out our hit result. So we take where we hit and our normal. This is identical to when we're holding something, except now since we have spawned in a new item, we simply tell it to set itself to where we hit and the rotation based on our normal. So this code right here is pretty much the same as when we are doing our line trace on the tick, except it's once we actually spawn in a new item. Scaling the decoration. Well, this one's pretty simple. Do we have a decoration we're currently holding? If you notice, a lot of this stuff is pretty simple based on do we have something and is it valid? Because if we don't have anything, it won't be valid. So this is kind of like an if check, except it's a nice condensed set of nodes. So are we handling decoration? If we are, we're going to set the scale relative to the parent on that decoration. So the handle decoration, static mesh is the target. And we're basically going to take the current scale. I'm going to add 0.1 based on the axis of the scroll mouse. So if it's scrolling up, I'm going to add 0.1 or multiply by a 0.1. If it's negative, it's going to be a negative 0.1, basically. Add that to our current scale. Clamp between 0.5 and 4. These are basically just values to make sure it doesn't go too small and too large. And set that to our relative scale. Deleting. Well, let's go to rotating. Rotating is basically the same thing except rotational values. The Q key, if we have a valid decoration, adds local rotation, -5. The E key, which we can ignore this part for now. Well, we can ignore this part for now. basically does the same thing. Are we holding a decoration? If so, rotate it in the other direction 5 degrees. All of these are local or relative, which is key. Relative scale, which means it only affects the mesh, and local rotation only affects the mesh, because we're storing the mesh's scale and rotation separate from the actors. So that way the actor holds the location and the mesh inside the actor holds the scale and the rotation. It makes it really simple when we want to put stuff down. Now, using these is-valid nodes actually helps us out because we have something already bound to our E key. Keep in mind when we are inside of our house and we go to the door, we can press E to exit. But if we are holding an item, the E key is... Oh, son of a gun. Let me go. I need to go back to the exterior. There we go. Let's go here. Keep in mind when we picked up the item, the E key rotates. But if we're next to the door, the E key is exit. Well, what do? Well, if in this case I'm holding something and I hit E, it rotates. It doesn't exit. But if I drop the item and then I try to exit, we exit fine. Well, how does that work? Well, it's pretty simple. I pass the interact key from the user interface back to my character. My character goes, hey, are we handling something? If so, we want to rotate. If we're not handling something, let's try to interact with whatever is next to us. Simple as that. It's basically this code here is the same as our interact code up here. And this code is the same as our rotational code for the other key, except they're combined into one, and it's situational. Interact with an item, we're going to go ahead and rotate. Interact without an item, we're going to go ahead and try to interact and exit. The last section here is deleting, and I put in 2 different ways because why not? Are we holding something? Yes. Delete that something from the world, and go ahead and set our handle decoration to nothing. Are we holding nothing? Well, are we targeting something that's a decoration? Remember, we keep track of our last decoration we hit. Well, we hit the delete key. We're not holding a decoration, but we are targeting a decoration. Let's go ahead and delete it and get rid of our reference. So that gives you 2 ways of deleting, either holding something or by targeting something. And of course, if you're not holding anything and you're not targeting a decoration, well, then nothing happens. That is all of the code that's unique for our character, and that handles all of our movement code. So if you notice, we have the manager inside the house handling loading and saving of the house, and we have the character handling placing, removing, deleting, rotating, and scaling. So we kept things as separate as possible. For the most part, that's going to be the code that we care about. We should look at how things are set up, and that's our next thing. So in terms of variables, we have our game instance. It simply holds the player transform for when we're going in and out of our rooms. We have the save game itself, which is just an array of interior objects, which is an array of our decoration struct. Our decoration struct is a struct that simply holds the class of our decoration, a transform where we put the actor's root for where it is in the world, and a transform where we're putting the mesh's rotation and scale. So our save game is basically going to consist of an array of those 3 variables that we save out for each item inside of our house, or we load up. Let's close this down. We have our interfaces, which again are pretty simple. They're just, hey, spawn the decoration. We tell the character to do that from the interface. And is this item interactable? If so, do something. Our text is simply text that shows E to enter, and it's showed or hidden based on the caller, which will be the player from the interior or the exterior. And the only reason these are different is this one says E to enter, and this one says E to exit. You can, of course, create one. This was meant to be super simple. And then our UI, again, is simply listening for input. We're listening for our key 1, consuming the input, and then spawning in whatever decoration I want, which is painting, bed, or light. Key Q is our left rotation. Our character handles all of our interaction stuff and all of our movement. So all our user interface does is pass key Q to our character and tells our character to handle it. And that's how we can handle key E for interact or rotate, because we're telling our character to handle it appropriately. Now our L key for the layout manager is pretty simple. Basically, we're handling it inside of here because it's unique to the UI and it's not unique to the character. We're not doing anything with L key except showing and hiding a widget. And all we're doing here is showing or hiding based on the current visibility of our L, which again is L show, L hide, L show, L hide. That's all we're doing right here. We should probably figure this out. Here, let's see if we can figure this out. Let me see. Where is that code? Okay, obviously here, let's figure out the code. Here, let's figure out what I broke, because I'm apparently breaking something. I put in some code for getting our character to spawn appropriately once they come back into the level. Here, okay. Let's see, graph save files, scripted access none, trying to read savable game instance. Okay, yeah, so this one's pretty simple. I knew this would come up, so I probably should mention this. We are using a save game instance. And the save game instance, again, stores where our player is when they entered and exit, so they come back to the right spot. But if you notice, if you may have noticed, when I was over here, and I entered this room, and then I exited, we're actually spawning over here. And when I enter here, we're spawning here. It's not the correct spot. This is my default player spawn, is where we're actually spawning at, right here. This error is indicating that it cannot access my game instance. What's happening is this is failing. Game instances are unique to the project. Because my example project has hundreds of examples, I've actually used the game instance more than once. Because of that, in my maps and modes, if you look, I'm actually using my persistent variables game instance and not my savable house game instance. So when I'm casting it, this cast is failing. In a production program, production game, you're only going to have one game instance. So this won't be an issue. This is just something unique to my project. But it shows a good way of an issue you may run into. You need to make sure you set your game instance in your project settings. Now if we were to run our example, we should get no errors. We should be able to enter and exit facing the correct way. When we exit, we should be able to go into our house over here and exit and come out at the spawn point on that house. So that's how we correct that issue. We have, lastly, our decorations. Now if we notice in our decorations, we have 4 decoration blueprints, an interface, a few icons, these are just images to show on our user interface, some materials, and then our actual static meshes. These are really easy to extend. Our decoration parent is simple. We have our root, and then we have a static mesh. Inside of here, on begin play, we create our glowy instance, and then we have an event to toggle the glow on or off. That's it. That's our parent. Each of our children is the unique properties for the child. So for our bed, if you notice, it's a data-only blueprint because none of the code is different from the parent. The only thing I've done different here is our mesh for our bed has the correct mesh and material and is aligned properly. Now by aligned properly, the item was created so that way the root point, or where I want it to stick, in this case the floor, is this location right here, the 0, 0. So if we look from the left, it's centered where I want it. And we look from the front, this is the back pivot point where it's going to snap to our wall. Imagine our wall is right here, or our floor is right here. And when we get it to snap, that's what it's going to look like. So if we look down, that's it. And our X value is forward because we're rotating around our X. So we want our bed to rotate like this. If we look at each of our other items, we're going to find the same setup. Our light is designed the same way. Oops. We have the X indicating where we want to rotate. So we rotate in this fashion, like this. And our pivot point is going to be the bottom right here when we snap to something. And our painting, of course, is identical. Our pivot point is going to be the back right here. And when we snap to something, it's going to look like that, and it's going to rotate in this direction. So if you were to create new items, basically as long as you keep that in mind, you create a child of the parent, you design your item appropriately, so that way it will snap to the correct spot, and that's it. That's all you need to do for adding new decoration. I could add any new decoration, design it however I want, as long as I make it a child, and I design it appropriately where it snaps in the right spot. I can spawn it in, and it's going to work perfectly fine. It's going to snap appropriately, it's going to scale appropriately, rotate appropriately, save appropriately, because we're saving everything that's a parent decoration class, and since these are children, they count in their hierarchy, and it's going to look. Our material is pretty simple. This is our base material. It simply has a color, which I can adjust, and it has a glow strength, which I can adjust. If you were to, for example, to have a real project, then your base color wouldn't be a color, it would be a texture. As long as this is the same, so it emits a green glow based on your glow strength, it's going to glow when you hover over it. And that is our simple go in, hover over something, and that's our green glow. And of course, since it's a green glow, we could of course adjust it. We could make it a, you can make it a yellow glow, I guess. And hit play. And it should give us a, should have given us a yellow glow unless I overrode something else. Let's see. Unless they didn't compile out properly. Let's find out, shall we? There we go. Yeah, it just wasn't done compiling. So now you can see we have a yellow glow. And of course, it's all adjustable in the parent material. I'll keep it yellow for now, why not? That's honestly it. That is the extent of our simple house interior decoration system. Once the basics are done here, you could just simply create a child, set up the correct mesh, set up the correct material, and inside of your user interface, if I wanted, for example, to have 4 to be my new item, I would put in a new widget. I would tell it to override key number 4. So, for example, I would just have it, override my key number 4 or whatever your inputs are for your designing and have it spawn in. This was an easy way of doing this and showing it as an example. Extendable ways would be, for example, your user interface could be a list of all the items in your scene. You could have a drop-down list, and then, for example, you could have an inventory. You click on the item in the inventory, it spawns it into the world, and then you do whatever you want with it. You could have a list of items. You could do whatever you want. If you wanted to extend this where you had some sort of an inventory, it's pretty simple. We have our character here. If we notice our interaction button here, how do we handle the action button? Right here, this is when we are done. We have an item handled, and we no longer want to handle it. After this, you could do remove from inventory, or add number 2, add +1 to the number of items we have spawned in the house, whatever you want. This is what happens when you take the item that's in the world and you let go of it, and it's now physically there. You would remove it from the inventory or do whatever you want for your code. This part right here is what happens when we pick up an item. So maybe once you pick it up, you know how we have, like, for example, the delete key. Once we delete a decoration, hey, are we handling something right here? Or any of these codes right here? Destroy the item from the scene, don't handle it, and then add back to the inventory. And right here, add back to the inventory. So now we've removed it from the scene, we've put it back in the player's inventory, and now they have it back. So that's how you could handle easily putting things back into the inventory from the scene, and then easily handle taking from your inventory and putting it into the scene. When you spawn something right here, this is basically saying, hey, we want to spawn something. We've put it into our scene at a certain location. Now let's go ahead and actually remove it from our inventory. Let's say we -1 from our inventory, or we gray the item out, or we do something to make sure we don't duplicate this item since we're already handling it. That's pretty much it. I'm pretty sure I handled all the items. Let me double check. We went over our houses. We went over our volumes, interfaces, our structs, our layouts. For example, let's say we wanted, here, let me show a quick extend on this one. Let's say we had our house B and we duplicated it. Let's assume I did this properly and I created a child blueprint. So let's say this was a parent and this is the child. And I called this one, house C. Let's take our house C and, we need to make it slightly different. So we're going to add a, where's the roundy thingy at the top? Where'd it go? Did I miss it? Here we go, a cone. And this one's going to look really silly, and it's going to have a cone on the top of it. But this is our house C. Okay? And it's got all the parent stuff. We can grab our house C, and we'll go ahead. Let me turn my lit mode back on. Let's move house C over to here. We'll put house C right here, for example. Okay? So there's our house C. We have no interior level name. Well, let's say we had house C map. So we'll duplicate this. This is our house C map. And, of course, it can look like whatever we want inside. But this is what's going to happen when we go to house C and we load it up. So now house C is going to load up this map individually. So if we were to run this and we go over to house C, we can enter house C. It's going to be empty because I've never been in here before. We can decorate it really shortly like this. We can exit. You'll notice we now came out of house C because we have an exit when we entered. We can go back in, and there's all of our places. We can go and slap a bed, like right here. We can have the multiple layouts, name it whatever we want. So this is going to be Alt-C, for example. We'll save out Alt-C, like that. We're going to go ahead and delete our bed, and delete 2 lights, because remember, when we leave, it saves to a default. We can exit. We can come back into here. Here's our default house. We could tell it to load up, Alt-C, like this, and it'll load up Alt-C. And there's our Alt-C layout. Obviously, there's no error correction or error code in there preventing people from loading up things that do or don't exist. There's no maps. This is just a simple concept. If you wanted to extend the loading and saving, for example, we would go into our house UI, and we have our loading and saving code. Oh, you know what? Yeah, here's our loading and saving code. I forgot to cover this. Okay, well, I'm glad I remembered. So this is our custom loading and saving. This one's pretty simple. When I tell it to save, we're basically copying the same code inside of our house manager. So that's something to think about. You may want to simply just contact your house manager and tell it to save it out based on the custom name. But in this case, I'm keeping it in the user interface to show you we're basically duplicating the same stuff. Create our new save game object and set it as a reference. We're going to go ahead and clear out anything that may be in there. This right here is pointless as we're creating a new one, but I'm going to go ahead and do it for continuity's sakes. I want to make sure this is completely clear. And it is, but we copied code, so it's kind of a old thing. Grab all of our decorations, store out all of our variables. Remember, same thing like when we're saving inside of our manager. Save game to slot, but this time instead of getting our level name, we simply grab the variable out of our text box and slot it in. That's it. So rather than saving to the current level, we simply grab our save name, which is inside of our text box right here, and we use that as our save game. Loading is going to be identical. We're going to grab the name out of our text box, check to see if it exists. If it does, load it up. Destroy everything inside of our scene. That's what this does. That's why it looks like we are loading up a new scene, but technically we're cheating. We are deleting everything in there and then grabbing everything out of our save game and spawning it in, just like our load inside of our interior manager. The difference here being we're just simply getting rid of everything that may already exist in our scene. And that's it. If you were to extend this to be a little more robust, you might want to have another variable you save, maybe your player's settings. It could have an array of house layouts. And the house layouts is simply names. It's simply text or string, whatever you feel like. The default value or the 0 array value could be the last one that they loaded up, or whatever you want as their default house. Maybe you have another button called default, and it saves it. Then everything else is simply another house name. So you have a default house name, and then you have the player saves, my awesome design as slot 1, my other awesome design as slot 2, my totally cool design as slot 3, and you simply update the array with their names after you save them out right here. And then in your user interface, you simply populate a drop-down list with everything inside that array, and you have a nice drop-down list that they can edit, work on, custom, delete, and you have some nice custom storage. I didn't want to add that in here because I wanted to leave that to anyone else who wanted to extend this. Again, this was supposed to be, and is technically, a simple concept for savable house interiors. So to wrap this up, I'm just simply going to rerun through the workflow and cover it to show how simple it is. Our character can enter any of the houses. The houses are all unique items that have variables attached to them that determine the interior map name. When we enter, we load up a completely new map. When the map loads up, the interior house manager checks for the save game for that map, and it's based on the map name. It spawns in new actors for every single decoration. Then it sets the location and the rotation and the scale based on those saved values. So we're basically just recreating the house from scratch. Anytime we mouse over a decoration, it glows. If we pick up an item by clicking on it, we can move it around. This is just a simple line trace. Now that's an issue right there that I did not fix on purpose because I wanted to discuss it. But basically this is a simple line trace. We're getting the normal of the line trace and flipping it, and that's where the attach point is on each of my items. We can scroll it up and down by changing the mesh's scale, and you notice there's a minimum and a maximum based on our clamp. We can rotate with the buttons along the x-axis. If you wanted to add in different rotational values, you could of course do that. I'm just simply rotating by adding rotation to the x-axis. We can drop it by clicking again, and by simply letting go of whatever we're holding on is all we're doing. Hey, we have something. Hey, we don't. Simple as that. When we exit, we are doing the opposite of entering. We're basically taking all the items, all of our decoration items, because they all have the same parent, saving out the values to the save game based on the level name, and then we are coming back out to where we started. And then when we enter, of course, we get the same thing. Now, I'm not going to fix this bug, but I just want to show you about this. Hopefully you can understand the issue with this right here. What's happening is the collision on this item. We want the collision on the item because if we place a picture here, we want it to collide on that other item. We want them to have collision like that. However, once I pick it up, it's colliding with the actor, my pawn. And that's why you're seeing this weirdness happen as it hits it. So one thing you might want to consider, because we do want it to collide with the pawn when it's in the scene. You might want to do something like, for example, this, and then you make like a little, you can make almost like a game where you have ramps that you're building up. The player can go up and down. What you'd want to do is when you pick up the item, simply disable the collision for the pawn, so that way when you move it, it's no longer going to collide with the pawn, and then when you drop it, turn the collision with the pawn back on. That's it. Extending the items is just simply extending the parent, and now that's it. I've covered the basics. That was the wrap up. I hope everyone enjoyed the video. I hope it shows some nifty ways of using things. As a small thing, I want to show you this. This is a backup character. When I originally tried to create this, I originally tried to use attachment points. Basically, we have a point on the character, and I use the attach to actor. Well, let's see, down here, right? There we go. I use the attach and detach component nodes to attach the item to physically be there, and then I change the location of my attachment point every frame. Because this point is on this, and then my attached item is attached to the actor where this is at, we started running into issues with rotators. Unrotating and rotating items based on the rotational value of this, which was based on the rotational value of this, which this item was then based on both. We started running into issues. So keep that in mind if you are going to work with attaching and detaching. You may run into issues where you're having multiplication problems with multiple rotators on attached items. So I left this in here just so you can see this was the original idea. The funny part about this is if you look at this code, this is the attachment code to deal with clicking and unclicking the mouse button. If we compare it to the current code we're using for clicking and unclicking, you'll see it here. This is the new code. This is the old code. So I had to do a lot of workarounds just to try to get it to work when I attached. When I've simply moved to the non-attached version and moving the item itself rather than attaching it, you'll notice the code cleaned itself up rather nicely. This was the code above right here, which was now this in this nice clean format. So I did spend a good half an hour, I spent about half an hour doing the attaching code here. I spent about 2 hours trying to get rotating to work properly before I switched over to the new system. Don't let it discourage you. That's a great part about Blueprints. You just get to screw around with stuff, have fun. If you run into an issue, take a break, rethink it, think about another way of doing it. Do not worry about scrapping anything you've done existing. If you're going to make it work better, that's the end goal. Get it working right. With that said, that is going to wrap up the concept video for savable, easy custom house interiors.